Okay, rational exponents. This is likely new for most of you. Kind of another exponent rule. So we're going to look for some patterns here. So it says evaluate or simplify each of the following. So when you square root 5, remember that's root of 25, which is 5. Okay, 5 to the 1/2 squared, power of a power, you multiply the exponents, so 5 to the 1 is 5. So these are the same, right? So that means that root 5 squared is, that means, I don't want to do the squared part. That means that because these are both squared, inside the brackets have to be the same. So root 5 is the same as 5 to the 1/2. So anytime you see a power or you have a fraction as the exponent, then that denominator of the fraction tells you what root you are taking. So I'm actually going to make this a little bit smaller. Really important to make that up high in the exponent place and make it a fraction in this case. Next one, let's see what this is. So cubed root of 4 cubed and 4 to the 1/3 cubed. So here, this, if we show this the long way, we'll have this times this times this, which is cubed root of 64, which is 4. Here, power of a power, you multiply the exponent, 4 to the 1, which is 4. So those are the same value. So notice how the exponents are the same. So that means cubed root of 4 is equal to 4 to the 1/3. Okay, so that was square root. This was a 2. Cubed root, this is a 3. Okay, so, and 1 is in the numerator. This one is a variable. So, can't simplify this, right? But what you'll notice is, if I look at this bracketed one, that means I have 3. Sorry, that's a, is that a 5 there? Yeah, it's a 5. So I have 5 factors of cubed root of x. So that is the same as cubed root of x to the 5th. So these are the same, okay? So that means these two expressions are exactly the same. So that exponent on 5 can be, that exponent of 5 on x can be on the inside or it can be on the outside of the whole radical. So these are equal. So to summarize, if we have a to the 1/m, then that's just the mth root of a. Okay? If we have a to the n/m, so the denominator tells you what root, and the numerator of that fraction tells you here what the exponent on the radicand is. So that would be n. Okay, now that's the same as mth root of a all to the n. So these are the same. So same thing here. This is the same. Now this is the nth root of a to the m. So that is the same as the nth root of a all to the m. Sometimes, if these are numbers in your radicand, it's easier to do this radical first and then raise it to the exponent m. For variables, it's usually easier to have the exponent on the radicand first, so this way. In any case, they all mean the same thing. Okay, so use exponent laws to evaluate without a calculator. So think about 9 to the 1/2. That is square root of 9, which is 3. Okay, and you can also think about it if you wanted to. 9 is 3 squared to the 1/2. 2 times 1/2 is 1. So sometimes it's easier to think about it expressing the base as a power, sometimes it's easier to think about using square roots. So this, with a negative, I always deal with the negative first. And then I go, oh, okay, that's the same as square root. Square root of 49 is 7. I don't even show any work. Here, if I were to do 27 to the 4th and then take the cubed root, that would be a big number. So that's where I like to show this as cubed root of 27 and then raised to the exponent 4. So should know that cubed root of 27 is 3, and then 3 to the 4th is 81. You don't have to show all of those steps. You can go right to the answer for this, but I'm showing you each step that I think about. Deal with the negative first, so 1 over 16 to the positive 3/4. I'm going to make that a little bit better. 1 over 16 to the positive 3/4. Okay, and then, so then I think about, okay, well, that's the 4th root of 16, and then I'm going to cube it. So 4th root of 16 cubed, 4th root of 16 is 2, cubed is 8, so that's 1 over 8. Here, again, I deal with negative exponent to make it positive. So 125 over 27, positive 2/3. Then I think about, rather than squaring this and then cube rooting it, I think about, okay, well, I'm taking the cubed root of 125 and then squaring it. Cubed root of 27 and then squaring it. Or you could think, so let's do it that way. So I think about taking the cubed root of 125. You don't have to show these steps because you can do this in your head. So that's 5 squared is 25, 3 squared is 9. What you could do is from here, you could go, oh, okay, well, 125 is 5 cubed. 27 is 3 cubed to the 2/3. Power of a power, so that's going to be 6 over 3, which is 2. 5 squared is 25. 3 times 2 over 3 is 2. 3 squared is 9. Okay, so you can use radicals, you can use powers, whatever. It's totally up to you. Okay, so in this one, just be careful. The 3 over 2 refers to everything inside that big bracket. So that's going to be 9 to the 3 over 2, and then 3/16 to the negative 2 times 3 over 2 is negative 3. So this is like an exponent of 1. So you multiply, and then you multiply those exponents. So now, think about this. Square root of 9 is 3. 3 cubed is 27. Okay, so you could, yeah, so I'm just going to go straight to that. And then here, to make that a positive exponent, that's going to be 16 over 3, all cubed. And then here, really, I know that 3 cubed is 27, right? So then it's 16 cubed is 4,096 over 27. Those divide out. Now, you could have from the 9 to the 3 over 2, you could think of that as 3 squared to the 3 over 2. And then you have 3/16 to the negative 3. And then here, when you take a power of a power, you get 3 cubed. And this you get 1 over 3, you get, 16 cubed over 3 cubed. And then those divide out. And 16 cubed is 4,096. This next one, so we've got big brackets, raised to the exponent 7. Inside, we have powers with the same base. Okay, so I'm going to start from the inside and work out. Powers with the same base, we're multiplying, so that's going to be negative 16 over 19. 2/5 minus 2/5 is 0. Well, 0 times 7 is 0. Anything raised to the exponent 0 is 1. Or you could show this as 1 to the 7 equals 1. Okay. And is that one. Okay, and then the next, putting it all together, more with variables here. So multiplying powers with the same base, we add the exponents. Notice how the denominators are the same. So 9 minus 3 is 6 over 4. So this is going to be 6 over 4, and we want to reduce that. So that's 3 over 2. Okay, it doesn't say express with radicals, so don't. Leave it in powers with positive exponents. Here, within the fraction, we have common powers with common bases, so we can subtract the exponents. So we're going to have 1/2 minus negative 1/3. Now, common denominator there is 6, so that would be 3/6 plus 2/6, which is 5/6. So this will be x to the 5/6 squared. Then 5/6 times 2 is 5 over 3. Okay, and that's it. That's all you can do. Next, coefficients would be negative 42. S is the variable. 7/4 plus negative 11/4 would be negative 4/4, which is negative 1. Negative 5 over 3 plus 7 over 3 is 2 over 3. And so we deal with the negative exponent. So that's just going to be S, and we don't show the 1. Okay, it's understood to be a 1. Next ones, we can simplify within. So 4 goes into 36 9 times. So this is going to be 9. Notice how x to the 4th over x to the 8 means we have x to the 4th in the denominator. Y cubed divided by y to the negative 1 gives us y to the 4th in the numerator, all to the 1/2. So now 9 to the 1/2 is 3. Y 4th to the 1/2 is y squared. X to the 4th to the 1/2 is x squared. Okay. I think that's it.